All right, so what we're going to do is we're going to look on page 287 at some examples of how to go from a word equation to a skeleton equation to a balanced chemical equation. All right, so look at number 4. We're just going to jump right in. If we read number 4, it says in water, so water's not part of the reaction, it's just happening in water. Iron 3 chloride, so I'm just going to write out what's happening. And so this is number 4. I have iron chloride reacts with sodium hydroxide. So what symbol am I going to use with reacts with? Plus. Sodium hydroxide. Producing, what symbol's going to show producing? An arrow. Producing iron 3 hydroxide. Plus sodium chloride. I ran out of room here. Sodium chloride. So that's what I'm going to call my word equation. And what it wants us to do, it wants us to take that word equation and make a skeleton equation, and from the skeleton equation, make a balanced chemical equation. So for the skeleton one, to make it, your periodic table is going to be handy to have, and your polyatomic chart is going to be handy to have. Because what it's going to do is we're coming to a culmination of everything that we learned before with the ionic and the covalent model. So I've got iron 3 chloride. First off, what two elements do I have here?
Iron and chlorine.
Iron and chlorine. So I know I'm going to have FeCl. So what's the charge on iron? +3. That's what it means in these parentheses. It's telling us that that transition metal has a +3 charge. What is the charge on chlorine? A -1. Okay, it's a -1. So, do those balance out FeCl like that? No. What do I need? 2 more chlorines for a total of 3. So what I'm doing is I'm writing these word compounds, I'm representing them with their chemical formula now, rather than words. So this is the second step. When I say skeleton equation, this is what I'm making with that skeleton equation now. Alright, sodium hydroxide. So I've got sodium. What's sodium's symbol? That's Na. Where do I find hydroxide? It's got oxygen and hydrogen, so it must be a polyatomic ion, and it is. If you look on your chart, you're going to see that hydroxide is OH. So what charge is sodium? Anybody remember?
2.
+1. It's in that first column. So it's a +1. Hydroxide, if you look on your chart, hydroxide is a -1. So can I leave that as it is? Yes, I can leave that as it is. I'm going to put this OH a little bit closer there. All right, produces iron hydroxide. So we've got iron is what symbol? Fe, and it's a +3. What charge was hydroxide? It's -1. So how many hydroxides do I need to balance out this iron? 3. 2 more, 3 total. Okay? So remember, I got to put that in parentheses then. FeOH 3. Are you following me? Have I lost you? We're basically reviewing a lot of the stuff that we've done. plus sodium chloride. So sodium is +1, chloride is -1. And what was my symbol? I heard you start to say it. NaCl. So there is your skeleton equation. So if I say write the skeleton equation, this is what we're looking at. Let me also ask you this in relation to what we did previously. What type of reaction is this? How would I classify this one? It's a double replacement reaction, because if you look, the Fe and the Na have swapped their partners. The Na was with OH, now it's not. Fe is and Na is with Cl, so that's going to be a double replacement reaction. So the next step, I went from a written equation or a word equation to a skeleton equation, but I now need a balanced equation. Is it okay with y'all if I erase the top of this? Okay, I'm going to erase the top of this just to make sure I have plenty of room up here and to clear some clutter. Okay, so what do I need to do when I balance equations? What's the first thing I want to do? I want to list my elements out. Okay, so I'm going to have iron, chlorine, sodium, oxygen, hydrogen. Iron, chlorine, sodium, oxygen, hydrogen. So how many Fe on the left? Remember your arrow is your dividing point. How many Fe on the left? 1. Chlorine. 3. Sodium. Oxygen. Hydrogen. Iron on the right. 1. Chlorine. 1. Sodium. 1. Oxygen. 3. Hydrogen. 3. All right. So what do y'all want to start with? Do you want to start with your chlorine, or do you want to start with your oxygen and hydrogen? Chlorine. All right. So chlorine's got 3 over here. How do we make it have 3 here? I'm going to have to put a coefficient, let me move that over a little bit. I'm going to have to put a coefficient of 3 in front of this. And yes, that gives me 3 chlorine. What does that do to my sodium? It also makes it 3. Okay. So now what do I need to do?
Put a 3 to the left one, put a 3 on the NA.
I'm going to put a 3 here. So that gives me how many sodium? 3. It gives me how many oxygen? 3. And it gives me how many hydrogen? 3. Am I balanced?
Yeah. No. Hey, yeah.
Yes, I'm balanced. I'm done. That's it. That's it. Any questions? I would call this a medium level one. There's some easier ones, but I thought y'all could handle this one. So I went with this. I think you can handle the hard ones too, but I didn't want to introduce it with a hard one. All right, let's look at number 5. We're gonna go to number 5. Now we're getting into some. That was all ionic bonding. Now we're going to get into a problem with some of this covalent bonding. So you're going to have to be looking at what kind of bonding you're doing to write these formulas too. Y'all got it? Okay. All right, I can always go back if you need me to. All right, so we're gonna look at number 5. First, I'm gonna write the word equation. So liquid carbon disulfide going to react with oxygen gas. Now remember, when I have oxygen gas or hydrogen gas or chlorine gas, it's going to be one of those diatomic molecules. What did the prefix di mean? Two. So when it reacts with oxygen gas, I'm going to have, I'm getting ahead of myself here, but I'm going to have O2. So carbon dioxide plus oxygen gas produces carbon dioxide plus sulfur dioxide. All right, so now I've got my word equation. I want to make my skeleton equation. I'm not trying to balance it out yet. I just want to write out what compounds I have. So what would carbon disulfide be? CS2. Because di means two. Sulfide comes from sulfur, so CS2. Plus, what did I say oxygen gas was going to be? O2. It's going to be one of those diatomic molecules. So it's going to be O2. We know what carbon dioxide is. CO2. Carbon dioxide. And so what would sulfur dioxide be? SO2. Alright, so I've got three elements. I've got my word equation, I've got my skeleton equation, and so now I've got to go from skeleton to balanced. So I'm going to list my three elements, CSO, and I'm going to list them in the same order over here so it's easy to compare. CSO. How many carbons on the left? Sulfurs. Oxygen. Carbons on the right. Sulfurs. Oxygens. 4. What do y'all want to start with? I'd say start with sulfur too, because anything you do with sulfur is going to affect oxygen, and you're going to have to come back and fix it over here anyway. So I've got two sulfurs on the right. How do I make two sulfurs on the left? How do I make two sulfurs on the right? I need a 2 coefficient. Remember, you cannot change the subscripts, just coefficients. So how many sulfurs does that give me?
2.
And now how many oxygens do I have? 6. 2 times 2 is 4, plus these 2, 6. Alright, so how do I fix my oxygen over here? Gotta put a 3. Questions? Now you have a balanced equation. Any questions? We're good? We understand? Okay. All right, let's do the challenge. It's actually pretty easy, I think. So I think we can handle it. Has everybody got this one?
This says zinc metal. Do we have to write like metal or just zinc?
No, we're just going to put just zinc. Now, in these equations, and I probably should be getting you to do this, I just want to focus on one thing at a time. You could be putting, if it is solid, if it is liquid, if it's gas, if it's dissolved in water, it's what we call aqueous. But right now, I just want you to focus on the words, the skeleton, the balancing. All right, so we're going to have zinc metal is added to a solution of dihydrogen sulfate. So I'm doing the word equation, so I'm going to write out dihydrogen sulfate. And that's going to give me a gas and a solution of zinc sulfate. And the reason this is a challenge is it wants us to figure out the gas. It wants us to figure out particularly what gas we're going to have. All right, so let's go to the skeleton equation. We've got zinc. When we write zinc, we're just going to put the element symbol. All right, and we've got dihydrogen sulfate. So, what is the first part of that going to look like? H2. Now, what is my charge on hydrogen? +1. +1. And sulfate, if I look at my chart, sulfate is going to be an SO4. Any guesses to what its charge is? Or if you got it in front of you, what's its charge? -2. So would these be balanced? If sulfate is SO4 and as a whole it's -2,
Yes,
and
ma'am.
you got 2 + 1s, yes, we're balanced. We're going to skip the gas for a minute. But now we have zinc sulfate. We know sulfate's -2. There's no Roman numeral here. But our zinc charge, we're gonna that's +2. I'm gonna give it to you. It's +2. So they're gonna balance each other out. That zinc charge is +2. So since they balance each other out, we're gonna have ZnSO4. ZnSO4. What do you think our gas is? Hydrogen. Because that's all that's left, right? We have the zinc and the sulfate over here, but that gas didn't transfer. I mean, well, it's not showing. It did. It's the gas. So it's hydrogen gas. Is that hydrogen atom going to be by itself?
Yes.
Yes.
What's going to go here? Just H? 2. It's going to be a diatomic molecule. It's going to be H2. All right, so let's see if we balance. We've got zinc, hydrogen, sulfur, oxygen. How many zinc? 1 hydrogen,
2,
sulfur,
1,
oxygen.
4.
All right, we do the same order here. How many zinc?
1,
Hydrogen,
2,
sulfur,
1,
oxygen.
4.
Am I balanced? Yeah, I'm balanced. Now, let me ask you this, going a step further. How would you classify this reaction? What type of reaction is this? Single replacement. Because look, zinc is single over here. And it says, look, hydrogen, can't have sulfate. I want sulfate. And so zinc goes and replaces the hydrogen, and now hydrogen is single in the products.
Hydrogen didn't want to show his faces.
I know. Any questions?